Hello students, welcome to beta function other form 5 and application problem. So let's get started. So this is the question, so problem. So we can define like this here, show that integral b to a x minus b power m minus 1 times a minus x power n minus 1 dx, which is equal to a minus b power m plus n minus 1 beta of m comma n. We have here m is positive and n is also a positive number. Okay, to prove this result, let's start the solution. Proof. To prove this result, I'll recall the definition of a beta function. Since we have, by the definition of a beta function, beta of m comma n, which is equal to integral of 0 to 1 x to the power of m minus 1 times 1 minus x power n minus 1 dx. So here we can suppose this is equation number 1. Now let's take for x equal to some substitution in such a way. So I should get here limits b to a. So which means the substitution contains a and b symbols. So let t is x equal to, I can say here. So let us take x equal to t minus b by a minus b is the suitable substitution. You have to remember this. This could be writing again like this, x equal to, I'll be writing 1 by a minus b times, I'll be writing here t minus b. Okay, now I can say this is equation number 2. Differentiate equation to both sides with respect to x. Differentiate 2 with respect to x. With respect to x on both sides. On both sides. In this case, we get LHS is 1. So which is equal to, we can say here. So otherwise directly dx equal to 1 by a minus b. It's a constant, remains same. Here t derivative is 1 minus, again we have 0 times dt. Otherwise you can say here, so dt minus 0. So anyhow the result is numerator is 1 minus 0 by a minus b times dt. So this will be equal to dx equal to, we can say 1 by a minus b times dt. Okay. After that it's a definite integral. So we need to go for limit substitution. Now limits will change. So here lower limit of x is, as per equation number 1, 0. Upper limit of x is 1. Now the next we will discuss about limits part. Limits here. So when lower limit, when x equal to 0, x equal to 0 in equation number, here it's equation number I'll give you. So this is 2. So in equation number 2. In equation number 2 already given. Okay. So when x equal to 0 in equation 2, LHS 0 equal to right side is 1 by a minus b times t minus b. From this cross multiply, when you cross multiply, t minus b equal to 0. So because a minus b times 0 is 0, so t equal to b, which means t lower limit is b. Okay. Now upper limit. From equation 1, the upper limit is x equal to 1 in equation number 2. In this case what happens, we will check. Now substituting in equation number 2 here. So 1 here, so 1 by a minus b times t minus b, then we will go for simplification. Now from here 1 equals to 1 by a minus b times t minus b. Cross multiply, when you cross multiply, a minus b equal to t minus b. So minus b same term, okay, cancel out with same sign. So t equal to a left. Therefore we can say that t limits are a to, so not a is the upper limit, b to a, b is the lower limit, a is the upper limit. This is my upper limit. Okay, u dot l I can say, this is lower limit. Fine. Now these results we need to substitute in equation number 1. This limit as well as this substitution, again this dx. 3 things we need to substitute in equation number 1. Here we need to change limits 0 to 1 with b to a. X means t minus b by a minus b. Here also x is there, 2 places x. Again dx means 1 by a minus b times dt. After that simplifying. So the next step what I can do here, therefore we can say, therefore we can say equation 1 implies, so LHS of equation 1 beta of m comma n which is equal to, right side is integral. We have t limits. These are t from b to a. Okay, we have x is there. So here we have x. X means we have to write t minus b by a minus b. T minus b by a minus b power m minus 1, which is multiplied by 1 minus x. 1 minus x means 1 minus t minus b by a minus b whole to the power of n minus 1 dx. Dx means 1 by a minus b times dt. After that, simplification. Now this is equal to, we can say here, integral t from its b to a. After that, numerator, when you separate here, t minus b power m minus 1 divided by denominator a minus b power m minus 1 multiplied with, again here the LCM is a minus b. If you multiply with a minus b here. Outside here minus is there. Minus times t, minus t. Minus times minus plus b. So anyhow, plus b minus b cancel out. I will be writing that step also. So here a minus b. Okay, here minus t. This could be plus b. Actually this into this multiply, you will get plus. Divided by a minus b whole to the power of n minus 1, again times 1 by, I will be writing under bracket a minus b. So power is 1 here dt. Let us suppose like this. Now minus b plus b cancel out. Here leftover part a minus t power n minus 1. So I will take new page. The next step is, here we have beta of m comma n is LHS, which is equal to, now t limits. Let us suppose t limits here. Limits are b to a. Okay, numerator. So we have numerator t minus b. So t minus b power m minus 1, which is divided by a minus b power m minus 1 times. Now we have here second bracket a minus t. So a minus t power n minus 1 divided by denominator a minus b power n minus 1. So take care here, 1 by a minus b power 1 d times t. It's not dx dt. Fine. Okay. After that, simplification, if you look denominator. So a minus b, a minus b, a minus b. Bases are same. Add powers. So when you add powers, m minus 1 plus n minus 1. Again plus 1. Plus 1 minus 1 cancel out. M plus n minus 1 will be the leftover part. So which means the next step will be, this is equal to integral t from b to a. Okay, denominator 1 by a minus b whole power m plus n minus 1, because plus 1 minus 1 cancel out. When it comes to numerator, t minus b power m minus 1 times a minus t power n minus 1 dt. Now the next step is cross multiply, because it's a constant total quantity. So we can take out completely outside. So here beta of, we can say, m comma n left side. Again this total denominator, when you cross multiply left side, so it will be multiplied with beta of m comma n, which gives a minus b whole to the power of m plus n minus 1, which is equals to integral t from, so b to a numerator. Okay, here right side is t minus b power m minus 1, which is multiplied by a minus t power n minus 1 dt. So this is what we want to prove. Or we can say, now change the left side, LHS equal to RHS, RHS equal to LHS in that case, and change the variable also. So by the definite integral property, now replace t equal to x. So wherever t is there, replace x. I am writing here. So b to a. So I am changing the variable t by x. X minus b power m minus 1 times. So we have a minus x power n minus 1. This is n minus 1 dx, which is equal to, I'll be writing a minus b power m plus n minus 1 times beta of m comma n. Hence the result. Next is application problem of beta function, other form beta function, other form phi. So we have, the question is given like this: integral 8 to 12 means lower limit is 8, upper limit is 12. So it is like x minus b, this is my b, this is my a, suppose that x minus b power this is only, it's not like m minus 1, you make it m minus 1. So 10 could be writing like 11 plus 1, okay, times a minus x. A means 12 here. 12 minus x power n minus 1 not there. We need to make it n minus 1 by writing 17 minus 1 is 16. So which is equal to 4 to the power of 6 beta times 11 comma 7. So how will you write? You have to, okay, to prove this result, one can remember the statement of other form phi. Since we know that, we can say, since we know that by beta function other form phi. So we need to recall. So beta of that is integral b to a. So we have x minus b power m minus 1 times a minus x power n minus 1 dx. This is equal to a minus b power m plus n minus 1 beta of m comma n. If you remember this one only, we can prove the above result. Okay, let us suppose this is equation number 1. Now if you look here, this equation, okay, as per this equation number 1, now we need to choose a equal to what is a, what is b, what is m, what is n. We need to decide 4 symbols. So by the inspection only we can decide. Okay, so if you look, let us take b equal to 8. In place of b equal to 8, lower limit is 8, upper limit is 12. Very clear. Again we have m plus n. What is m comma n? First of all, so m minus 1 I have to be right. What is m minus 1? This is our m minus 1 result. This is not m minus 1. This is n minus 1, which means, so m minus 1 equal to 10. From this I will get m equal to 11. Similarly, we have n minus 1 equal to 16. From this I will get here n equal to 17. After that, so substitute all these results like b value, a value, again m minus 1, m, again n minus 1, n in equation number 1. I will get the above result. The next step is therefore equation 1 implies, so we can say here integral 8 to 12, so followed with x minus b. X minus b means x minus 8 power m minus 1 is 10, which is multiplied with, okay, a minus x, 12 minus x power n minus 1, that is 16. So which is equal to right side a minus b, 12 minus 8 power m plus n minus 1. M plus n is 11 plus, okay, 17. So that is, so we have 11 plus 17 is 28. So m plus n minus 1. So 11 plus 17, 28. Okay, minus 1 multiplied with beta of m comma n. M comma n is 11 comma 17. Okay, this will give you answer 4 power 27 multiplied by beta of 11 comma 17. So here a small correction. So this question is 4 power not 6. So here 4 to the power of 27, that is m plus n, means m plus n minus 1 times beta of or b of m comma capital B or beta, the meaning represents same, beta of 11 comma 17. Okay, so this is the final result. Thank you students. Thank you for watching.